What if the story of Puerto Rico's first settlers is completely wrong? What if instead of a single local group slowly spreading through the islands, the early people came from completely unexpected places, across oceans, through jungles, and along forgotten island chains? For years, the narrative seemed simple. But now, ancient DNA is revealing a complex, layered origin story of migration, isolation, and resilience. So, who were these first islanders? And where did they actually come from? Before we start, I'm on a road to get 1,000 subscribers as a small channel. If you want to help me, please subscribe. Let's dive in. Puerto Rico may seem like a small dot on the map, but it's always been a major crossroads in the Caribbean. Situated between the Greater and Lesser Antilles, it's a strategic point where ocean currents and island chains intersect. For decades, scholars believed that the earliest people to settle Puerto Rico were part of a gradual expansion from nearby regions, perhaps fisher-gatherers from South America or mainland migrants from Central America. Archaeologists divided the early history into neat cultural periods: the Ortoroid, thought to be the first wave around 4000 BC, and the later Saladoid, who introduced agriculture and pottery. But these divisions were mostly based on artifacts, stone tools, ceramics, shell middens, not DNA. Without genetic data, the deeper origins of these people remained unclear. Were they all from the same ancestral group, or had different peoples come to the islands at different times, bringing separate identities with them? The answer was buried in bone. Extracting DNA from ancient remains in the Caribbean is no easy task. Puerto Rico's tropical climate, with its heat, humidity, and frequent rainfall, breaks down genetic material quickly. Bones and teeth degrade fast, leaving behind only fragments, if anything at all. For decades, this meant researchers had to rely on archaeological clues alone. But recently, advances in ancient DNA technology changed the game. Scientists began using a technique called hybridization capture, where tiny molecular hooks target specific sections of DNA known as single nucleotide polymorphisms, or SNPs. These are the points in our genome that vary between populations. By focusing on over 1 million of these SNPs, researchers could piece together enough of the ancient genomes to uncover ancestry. Even a few surviving cells from ancient teeth or bone could now reveal thousands of years of hidden migration. Puerto Rico, long considered genetically silent, finally had the chance to speak through science. Puerto Rico's archaeological sites are like puzzle pieces scattered across time. One of the oldest clues comes from the site of Puerto Ferro on Vieques Island, where a stone burial circle was uncovered decades ago. Nearby sites like Angostura, La Hueca, and Mezabel revealed shell middens, hearths, and early human burials, some dating back over 4,000 years. These early sites were thought to belong to the Orinoco people, hunter-gatherers with a coastal lifestyle relying on fish, shellfish, and wild fruits. Then came a second wave. Around 430 to 250 BC, Saladoid groups arrived. They brought with them finely painted pottery, root crop agriculture, and village life. Their settlements spread quickly across the island, marking a major cultural shift. Until recently, it was assumed these newcomers simply replaced the earlier groups. But with DNA now available from ancient remains at these sites, the picture is changing. These weren't just cultural shifts, they were migrations with entirely different genetic origins. When scientists sequenced ancient genomes from Puerto Rican archaeological sites, the results turned expectations upside down. Using principal components analysis, a method that clusters DNA based on ancestry, they found that the earliest individuals didn't align closely with North American indigenous populations. Instead, they were genetically closer to ancient groups from northern South America, particularly along the Orinoco River basin. This discovery matched long-held theories about coastal migrations, but added genetic confirmation for the first time. Even more surprising was the discovery of at least one individual who showed clear signs of admixture, mixed ancestry between archaic foragers and later ceramic age farmers. This meant that while most groups may have remained genetically distinct, there were rare cases of interaction and integration. These findings suggest that the peopling of Puerto Rico was not a simple one-way migration, but a layered series of movements, each bringing different genetic signatures, cultures, and survival strategies to the islands. The DNA evidence revealed 2 major waves of migration into the Puerto Rican islands, each with distinct origins and lifeways. The first wave, the Orinoco people, arrived over 4,000 years ago and likely came from the northeast coast of South America. They were coastal foragers, moving through the Lesser Antilles in small boats, settling where food was plentiful. Their genetic profile suggests deep roots in the archaic populations of the Orinoco region. Then, more than 1,000 years later, the Saladoid people arrived. These ceramic age migrants weren't foragers, they were farmers. They brought with them agriculture, pottery, and village life. Their ancestry linked them to Arawakan-speaking populations of the Amazon and inland Venezuela. DNA showed a clear distinction between these two groups. Though they occupied some of the same islands at different times, or even simultaneously, they remained genetically separate. This dual migration model reshapes how we view Puerto Rico's early settlement history. Despite centuries of potential overlap, the genetic data shows remarkably little mixing between the Ortuaroid and Saladoid peoples. Only a single individual showed signs of both ancestries, and even that case was modest, about 13% admixture. This suggests that the two populations remained largely separate, possibly by geography, language, or culture. They may have lived in different regions of the island or held on to distinct social boundaries that discouraged intermarriage. It's rare to see such long-term separation between neighboring groups, especially in island settings, but in Puerto Rico the DNA tells a story of coexistence without convergence, a tale of two peoples side by side but apart. To go deeper, scientists examined the mitochondrial DNA passed down from mothers and Y-chromosome DNA from fathers. These markers help trace family lines over thousands of years. In Puerto Rico's archaic individuals, maternal haplogroups like D1 and C1d appeared. Lineage is also found in early North and Central American populations. But the ceramic age migrants carried different signatures, B2, C1b, and C1c, which are much more common among indigenous groups in the Amazon and northern South America. These contrasting lineages confirm what the broader genome already hinted. Puerto Rico's early populations weren't a single continuous people. They came in waves from different worlds. These layered migrations help explain the roots of the Taino people, who greeted Columbus in 1493 and whose legacy still resonates today. The Taino weren't a single origin group, but a cultural identity shaped by centuries of movement, interaction, and selective integration. While their language and material culture align with the later Saladoid migrants, the genetics reveal deeper complexity. Some modern Puerto Ricans still carry maternal haplogroups traced directly to these ancient islanders, especially from the ceramic age populations. In fact, studies show that up to 61% of Puerto Rican women today have indigenous mitochondrial DNA. That means the legacy of the island's first peoples lives on in the very DNA of its current population. Rather than being lost to history, the Taino and their ancestors are embedded in the genetic fabric of the island. Ancient DNA hasn't just clarified where people came from, it's helping modern Puerto Ricans rediscover who they've always been. This new genetic evidence is only the beginning. Many ancient sites in Puerto Rico remain unexplored or unsequenced. Submerged locations, like those off the coast of Vieques, may hold even older remains that could rewrite the timeline further. Researchers also hope to expand sampling across other Antillean islands to better understand the stepping stone routes these ancient seafarers followed. What's clear is that the Caribbean wasn't a backwater, it was a hub of migration, adaptation, and survival. Each ancient genome is a voice from the past, and together they're telling a much richer, more interconnected story than we ever imagined. The story of Puerto Rico's first inhabitants is far more complex than anyone imagined. Ancient DNA has revealed that the island wasn't just settled once, but many times by different people navigating by sea, guided by currents and survival. Their cultures rose and faded, but pieces of them remain in bones, in language, and in the living descendants of today. So what other migrations lie hidden in the island's soil and sea? Let me know in the comments. If you enjoy uncovering deep human stories through science and history, check out the Patreon, and don't forget to like and subscribe. Until next time, stay curious.